Hey, and welcome to our practice set for standard form of a line. Like and subscribe if you find this video helpful, and drop me a comment or a question below and let me know what you think or what questions you have. As always, pause the video here to work these problems on your own, then come back and check your work. All right, so the first several problems in this problem set are all about writing these in standard form. So we're going to take these in chunks of 2 until we get to the ones that have a little bit more work. So the first one, we've got 2x minus 5y plus 7 is equal to 0. And remember, standard form is ax plus by equals c. So by our directions, we have got the ax, we've got the by, but the c is in the wrong spot. Okay, so that 7 does not need to be there. We need that 7 kicked over to the other side. That is a positive 7. So we will be able to get it on the left-hand side by subtracting it. We're going to subtract it from the right-hand side also, and that'll give us 2x minus 5y. 7 minus 7 is 0, so that cancels out, and 0 minus 7 is negative 7. And there's our ax plus by equals c. So in this case, a is equal to 2, b is the negative 5, and c is the negative 7. All right, next one is in slope-intercept form, but thankfully we don't have any fractions this time. So we've got it in y equals mx plus b form. We need it in ax plus by equals c form. And so essentially we need to get the x's out of there. So that's a positive 3x. And if this confuses you, please go back and check out the lesson video. I did go through this in some detail in the lesson, like when you're subtracting, you're really adding a negative. And so what we end up with there is negative 3x plus y equals 8, because 3x minus 3x is 0, leaving us with the 8. And this, you could think of it as y minus 3x, but remember, subtraction is just adding a negative. And then you can switch the order to give you negative 3x plus y. I just did not do that, okay? I did not do all those steps. And hopefully, if you've been doing problems the right way all the time, you get to where you're comfortable with this. If you're not comfortable with it, okay, whether because you haven't done all the practice that you should have done, or because it's just taking you longer to get comfortable, you are welcome to kind of go through this step and show that work. Okay, never shortchange your work, like show all the things. So y minus 3x, because you're subtracting 3x, remember that subtraction is adding a negative. And then once you have it in adding, you can apply commutativity, which says the order that you add things don't matter. So y plus negative 3x is the same as negative 3x plus y. And that is in standard form, okay, where our a value is negative 3, the b value is 1, and the c value is 8. So if that maybe threw you for a second there, the b value there is 1, because 1 times y would just be y. Right, these next two do have fractions in them, and so we did 1 or 2 of these in the video lesson. I like to clear of fractions first. I think there's probably some people that prefer to get the x over there on the left and then clear of fractions, but that's just not how I've ever done it. We are dividing by a 3, and so the way I get rid of dividing by a 3 is I multiply by 3. If I multiply by 3 on the right, I have to multiply by 3 on the left, but notice that I am multiplying everything on the left by 3, and here on the right I'm only multiplying some of the stuff by 3, which means that these are no longer equal, because this is getting more 3 multiplied in than this one is. To make that okay, we got to make sure we multiply everything by 3. That is going to give us 3y. The 3's here are going to cancel out, leaving me with 1x, and then 4 times 3 is 12. then we need to kick that x on out of there. So we're going to subtract the 1x. And this is exactly what I went over last time with the subtraction. Okay, I won't belabor it and like make this video super long by going through it again, but you could do like 3y minus 1x, and that's plus negative, and then switch the order. 1x minus 1x is 0, leaving me with 12. Now you could stop here. All right, where A is -1, B is 3, and C is 12. Most of the time, however, you will not see the 1 there. It will simply show up as -x, because 1x, 1 times x, is just x. And so you'll see that as -x. All right, next one. We have y equals 4/7 x plus 6/7. And strategy is the same. Just because it looks a little bit different does not mean the math has changed. If you've got this divided by 7, we don't want a divided by 7, and we can undo that by multiplying by 7, and we have to multiply everything by 7. So we will end up with 7y, 7's here cancel out, leaving me with 4x, and 7 over on the right will cancel out, leaving me with 6. We need to get that x on out of there. Okay, it needs to go over to the other side, and I'll end up with not a -14. Definitely not that. Let's try that one more time. -4x plus 7y equals 6. Because 4x minus 4x is 0, leaving you with the 6. And then, of course, that negative goes with the 4x. So there we go. It's not a lot of work. If you're staring at your page right now and you have mountains of work for this, you're doing too much. This took me like 1, 2, 3 steps. If you did some of those middle steps, maybe you'd be looking at 4 or 5. But if you are looking at more than 5 lines worth of work, you have done too much work. Okay, you want to figure out like what are you doing that is taking you through some steps you don't want. All right, next one is presented more in words. So instead of giving you the equation, so this one is write a equation in standard form with a slope of 4 and going through the point -2, -6. So for this, we actually need to do some work at the get-go. So we can't use standard form at the outset. We're going to have to start this in slope-intercept form. We know that the slope, which is the m value, is 4, and then we're going to borrow the x and the y out of that point. So we will have -6 is equal to 4 times -2 plus b. -6 is equal to -8 plus b, and then we'll get that 8 out of there by adding 8 to both sides. -6 plus 8 is 2, -8 plus 8 is 0, and I get b is equal to 2. Now, all of that work to just get this in slope-intercept form, which is y equals 4x plus 2. But now from here, getting it into standard form is just a matter of subtracting the 4x from both sides. So we have -4x plus 1y is equal to 2. So that one really taps into previous skills. There is an entire lesson on how to write the equation of the line given the slope and any point. And the whole lesson is just how to get to this process, like over to here where you have the y equals 4x plus 2. So if that's something you don't know, please go back and check out that video. Okay, go back and check that out because again, the skills start to build. And if you're missing something earlier on, it will be so much better to take 20-25 minutes now and go fix that than it is to say, I don't want to do 20-25 minutes now, I'll just keep going. And then you have, it's like a building on a foundation with a hole in it. Like just go plug that hole. Oh, I like lost everything on this slide. I did most of this problem out and then lost it when I realized I made a copy mistake in my notes earlier. So I guess I'll do this problem again. All right. So this one is write the equation of a line going through 2 points. And there is, again, an entire lesson on this skill. So if I lose you somewhere in the nuts and bolts of this, you need to go back and plug the gap with this particular skill. To do this, we are going to start with the formula for slope. And I need to pick a 0.1 and a 0.2. So I'm going to go ahead and pick the first point as 0.1 and the second point as 0.2. But you can pick them any way you want. And then we have to plug in to the formula. So this will be -3. Sorry about my handwriting. My thumb is still taped up. It's going to be taped up for a while. -3 minus 4. And I don't know if the microphone picked up the thunder outside, so just started thundering. -3 minus 4, and then x2 is 2 minus -1. Now, this is a spot where it might be really, really helpful to remember that subtraction is adding a negative. So -3 minus 4 is the same as -3 plus -4, and 2 minus -1 would be 2 plus +1. It's the adding of the opposite. A lot of middle school teachers will say keep, change, change, okay, as a way of remembering that. I'm not a fan of keep, change, but adding the opposite. -3 plus -4 is -7. And then 2 plus 1 is 3. Now we've got to do what we just did in the last problem. We've got to go find the y-intercept. And this is not shaping up to be really great. We're shaping up to deal with some fractions here. I'm going to go ahead with 0.1, and we'll just use those values for x and y. So y would be 4. My slope is -7/3, and my x value is -1, and we're looking for b. -7/3 times -1. A negative times a negative would give you a positive. And then we need to figure out what b is, which means we need to subtract 7/3 from both sides. So I'll go ahead and subtract 7/3 and subtract 7/3. So now I've got 4 minus 7/3 is equal to b. If you've got a calculator that will do this for you and you're allowed to use it, now is a great time to just like throw it in your calculator, 4 minus 7/3, and make sure you know how to get the fraction out of it. If you are not allowed to use a calculator, so a lot of times in Algebra 1, there are big non-calculator sections. Then what you need is a common denominator. The denominator that we're looking for is 3. So a pretty foolproof way to get that denominator is to multiply by 3/3. 3/3 is equal to 1. And so you're going to be doing 1 times 4, which means whatever we get is going to be equal to 4, because multiplying by 1 doesn't change anything. 4 times 3 is 12, and then you end up with 12/3. And if you stop for a second and think, 12 divided by 3 is 4. So what we've done is we still have 4 minus 7/3. We just have 4 written with a denominator of 3. 12 minus 7 is 5. And I end up with a y-intercept of 5/3. This is where I paused the video before because that is not the number I have in my notes, and it's because I miscopied a number, and love that for me. I had to do the problem all over again. Makes me good at doing the problems. So what we've got here now is a slope of -7/3 and a y-intercept of 5/3. That's your answer in slope-intercept form, but we are asked for it in standard form. So as before, if you've got that fraction, we need integers. We're going to multiply by the denominator. Make sure you multiply everything. So 3 times y is 3y. This would be -21/3, which would be -7, or an easier way to think of it is just multiplying and dividing by 3 cancel each other out. So we get 7x, and then multiplying and dividing by 3 cancel each other out, and you're left with 5. Or if you really want to say like 5 times 3 is 15, and 15 divided by 3 is 5, like go for it. Now we're almost there. So the last thing I need to do is get the x over to the other side. So I'll add that, and I will get 7x plus 3y is equal to 5. Okay, that was a fairly long problem, but it involved a lot of skills that you should already have. How do you find the slope? Okay, so there's a whole lesson on that. Just how do you find the slope given 2 points? There is an entire lesson on how do you write the equation of a line given 2 points. And then, of course, we have this lesson on how to go from slope-intercept form to standard form. So at any point, like, you have to be able to draw on your older math skills to be able to do the new math skills. And like, my students feel like, okay, I took the test on that, I can forget it all, but you can't forget it all. Okay, you have to remember it. So if you need to go back and rewatch some videos, or maybe watch them for the first time because you need a refresher, please, please, please do that. Okay, third time's the charm on this slide. So we are going to graph this line 2 different ways. We're going to go back to some of our old school skills of creating a table and plotting points, because we never want to lose sight that that is one of the tricks we have in our pocket. Sometimes we get so wrapped up with our shortcuts and our faster ways of doing things that we forget that even though it's like kind of a long deal to create a table, it still works. So the table works like this. You can pick any values for x that you want. Now, I'm going to pick 0, 4, and -4. 1, because I already did this problem and I know that those numbers will come out nice, but also I knew they were going to come out nice by like staring at the problem. And that comes with like 30 plus years of experience of doing this kind of problem. You might have picked other numbers. That does not mean you did anything wrong. It just might mean that the numbers you end up in your graph, in your table, are like yuckier numbers. So once we have our values for x, what we do is we plug in those values for x and we find the value of y that goes with them. So I start out with the 0. 3 times 0 is 0, leaving me with 4y. Divide both sides by 4, and I get y is equal to 3. 12 divided by 4 is 3. So the point 0.03 is on the graph of that equation. Now I'll do the same thing, but with a 4. Okay, 3 times 4 is 12. Now I have to subtract 12 from both sides. So 12 minus 12 is 0, leaving me with 4y. 12 minus 12 over here is also 0. And there's more thunder. So I don't know if it's raining, but it's definitely thundering. All right. So you can divide both sides by 4, and a lot of my students here will be like, oh, I must have done something wrong because, I don't know, 0 is not a number. 0 is a number. 0 divided 4 different ways is still 0. So if you have $0 and you're going to split it like 4 ways so you and your friends can buy pizza, guess how much pizza you're getting. But you could also think of it this way. 4 times what would give me 0? So like, what 4 times what number could you plug in here that would give you 0? It would be 0. So the point 40 is also on the graph. So if I come over here and I plot 0, 3 and 40, I actually don't need any more points. 2 points is enough. The third point is always just a check. It's because we're doing some algebra, some substitution in here. And there's always a chance that we're going to do something wrong. So you do the third point and you hope that the third point doesn't like make a triangle. Okay, we want it to be on the line with the others. So here we'll have 3 times -4 plus 4y equals 12. So now we have -12 plus 4y equals 12. Add 12 this time. So 4y, -12 plus 12 is 0. 12 plus 12 is 24. Divide by 4, and I get y is equal to 6. And so coming over here, -4, I go up to the 6, and I breathe a sigh of relief because, yes, that point is on the same line with the others. And I will do my best to connect these with the straightest line that I can. Better than the first time I did it. Now, here's what might have happened. If you picked other numbers, okay, you will have different numbers in your table, and you might have some really awful numbers, some like awful decimals and stuff. And so when you come over here, you're going to have to estimate. You're going to have to estimate like where. And so your points might be in between mind. They're like being estimated. Like, I think this is, 2, 1 1/4 or something, whatever that ends up being, but they should be on the line. So if what you're looking at looks mostly like this, you're okay. If your line goes this way, okay, that's not okay. If your line has a y-intercept way down here, okay, that's not okay. But as long as your points are like reasonably close to like, yes, I think they're on the same line as hers, then you're doing okay. Now, second way is to use slope-intercept form. And so for this, we want to get it to be y equals mx plus b. So we need to get the y by itself. So we will subtract the 3x. Now, 3x minus 3x is 0. I'm totally okay with just saying negative 3x plus 12. But you might be more comfortable saying, okay, that's 12 minus 3x. That's 12 plus negative 3x, and then switching the order here. So you have negative 3x plus 12. Do what makes sense to you where you don't feel like you have the magic happening, okay? Now we want to get the y by itself. We divide everything by 4, and so we're left with y is equal to negative 3/4 x. 12 divided by 4 is 3. Now, graphing it this way, I will change the color up. We'll use purple. The y-intercept is 3. Oh, look, that is the same point that we got by building the table, okay? And so we're confirming like, yes, like this is going to be the same line. Now, the slope here is negative 3/4. So that means we're going to be counting down. No. This is what happened before. I have like a weird pop-up. And I clicked like end show before. Down 3 and right 4. So starting at the y-intercept, I'm going to count down 1, 2, 3, and right 1, 2, 3, 4. And what do you notice? It's the same point. And you could count down 1, 2, 3 again and over 4, and it gives me that point. So maybe that point was 1. Maybe we're going to count up 3 and left 4. That would land us over there. But either way, what I wanted you to see with this was that you have the same line. Which way is better to graph the line is completely up to you. It is what makes the most sense to you, what is going to give you the confidence that you've put those dots in the right places. So I have had students that when they try to do this process, it is an absolute train wreck. But if they build a table and fill it in, they're going to get the line in the right spot. And that's the important thing, is that you can get the line in the right spot. Okay. All right, that's it. Like and subscribe for more math help. Drop me a comment below and check out some of the other videos and playlists on the channel. I've been making videos for a little while now at the point that I'm recording this, and we've got some playlists on just multiple choice questions. I've got some that I'm putting together on Desmos, so please feel free to go and check those out, and I will see you in the next video.